When prototyping thin silicone parts such as this one, we're looking at about 1/2 to 1.5 millimeter wall thickness on these parts. It can be particularly challenging to find any printing technologies that will accurately reproduce this shape. To give an idea just how thin and flimsy this part is, it's so thin that it has a trouble filling in any traditional casting techniques. We found that vacuum casting is a great way to improve the quality of the parts that we're prototyping and continue learning and advancing our design. To do this, we make a small PLA mold by designing an upper half and a lower half and combine extracting the geometry out of the part to allow us to have printable geometry. This mold prints in about 1.5 hours. Running the parts in parallel on 3 separate printers allows us to set the accuracy per part and the layer thickness that will get us the fastest build. We use CRC general purpose silicone mold release on the PLA molds. We have found the smooth-on universal mold release to cause mold inhibition with silicone, so I do not recommend this for this method. I give each part a brief shot of mold release, just enough to coat the surface. These deep holes do not need mold release. The vertical walls release the silicone very well without it. These molds go together with no fasteners, so we have an upper mold and a lower mold, and I put those face to face, and I slip them into the cup, and I press them down until they snap in place. I have 3 snaps around the outside. Those help hold the upper mold down into the cup. I then take a hot glue gun and I put a dab of hot glue on each of the snaps just to ensure that that upper mold won't be moving around during the vacuum casting process. And then I seal any remaining air gaps in the tool so that the vacuum will not draw air into the rear half of the tool. We need the vacuum to draw the silicone only down the vent holes. When all the molds are assembled, we're ready to start filling them with silicone. I'm going to tear the scale with my mixing pail. I'm going to pour in part A into my mixing tub. So I have 272 grams of part A. I need 10:1, so 27.2 grams of part B. So I'll tear this out, go up to 27.2. That's close enough. I'm going to mix this very well and ensure I'm scraping the sides of the container to get good A and B mixture. Make sure I'm cleaning out my stir stick, and all these steps we have recorded in a process so that we can continue to improve our reliability of our cast parts. I recommend that. Sometimes we miss the easy steps because we forgot something or we haven't done it for a while. Let me know and I'll share that with you. After stirring thoroughly for a few minutes, you can see that the silicone is very white. There's lots of entrained air in the silicone, so we're going to use a vacuum chamber to degas this mixture. So to do that, I'm going to place it into this chamber. And turn it on. Wait for the needle to start moving, so I have achieved vacuum. As the vacuum is pulling the air out of the chamber, you'll see that the bubbles are starting to grow. As the bubbles are growing towards the top of the chamber, I'm going to keep an eye on it so it doesn't overflow. We're waiting for those bubbles to collapse. Bubbles are cresting, so I'm going to let some air back in. This will cause some of the bubbles to break. If I had done this in 2 separate containers, we could have degassed it without this step. The second time through, you can see the bubbles are starting to crest with full vacuum, and they're starting to collapse on their own. This indicates that the silicone is sufficiently degassed. We'll wait until it collapses completely to the bottom, and then we'll pour it into the molds. The silicone is much more clear after degassing, but there's still a few bubbles remaining, and those will be pulled out during the vacuum casting process. As a note, I've switched to vinyl gloves versus neoprene gloves, as we've found that neoprene gloves can inhibit curing of the silicone. I'm going to pour the silicone from a height down into these molds, and you'll see the silicone start to spill over the edge and neck down, and it will create a thin stream as it goes into the mold. And this is intentional, as it removes any remaining large bubbles from the silicone resin. So you can see there's a few bubbles here, and then as they come down in here, they're stretched and popped. And because this silicone doesn't stick to much once it's cured, I don't worry much about getting it on my workbench. It scrapes off really easily. But I'll come through here and I'll fill all these molds with about 1/4 of an inch of silicone into the cup. Also, I've mixed a lot more silicone than I believe that I need, because I don't want to ever scrape the inside of my jug. I found that I can get uncured silicone off the walls, or insufficiently mixed silicone. So these are now full and they're ready to go into the vacuum chamber for a second time. So now we're going to turn the vacuum chamber back on, and we're going to draw the air out of the molds so that atmospheric pressure can push that silicone into the tool. So you'll see many big, large bubbles coming out of the vent holes and around the edges as the vacuum chamber depressurizes. We normally leave these sit in the vacuum chamber for about 20 minutes. The bubbles will continue coming out of the mold as the molds are evacuated of air. Okay, these molds have been sitting about 20 minutes. We're going to assume that the air has all escaped the molds, and we're going to slowly let the air back into the chamber. So now again, the silicone is being pushed into the vents and throughout the mold cavity. Depending on the viscosity of your silicone, you may want to let the air in slowly or more quickly, and you can experiment with that. So we're going to transfer the molds into the pressure pot. Close it up. And tight. We'll pressurize the chamber. 4 atmospheres of 18 hours in the pressure pot, and we can take the parts out of the tank. We're going to use an arbor press to push the parts out of the mold. Pull the extra silicone out, snipping the vents. And if this molds are stuck together firmly, we'll pry them apart. A good mold design will have a gap in here that you can put a tool and pry the parts apart. We're going to pull the silicone has a good elasticity, and you can pry it out pretty easily. We'll peel this part off the tool. A little bit of flash to trim, but that's a good looking part. We'll trim the gates.